2003, question 6B. So 2003, 6B. And this is on circular motion. Okay. Particle of mass m is held at a point P on the surface of a fixed fluid being the key word. Okay, no friction. Center O, radius R. OP makes an angle A with the vertical. The particle is released from rest. And then I'm going to let this phi1 equals 0, phi2 equals phi. And the particle is released from rest. When the particle reaches an arbitrary point Q, the speed is phi. Okay? Now, I don't know if we're guaranteed about this arbitrary point is, it's still in contact maybe. Do you understand? We aren't told it's the point at which it's leaving at. So we can't do R equals 0 because we're not guaranteed it. Okay? So it's not leaving. So we're just going to draw the circle. I might draw two different circles for the two different points to make things a bit clearer. Okay? So point 1, this one here. Point P. And then the second one is going to be point Q, which is over here. Okay, so there's two circles is sometimes better than one because you're not going to get your two diagrams mixed up with each other, okay? So, angle alpha, angle beta. We also know that this is R, that is also R. Okay, sorry? Oh, that's angle.
That's not angle beta.
It is. It is.
It's going to the vertical.
It is.
Here?
Angle beta is like, it's angle beta plus.
No, it's not.
No, sorry, I get what you're saying. It could be angle alpha plus angle beta, but you can see that the line starts here and ends here. It's good that you're looking for it though. Okay? Now, what we're going to do is, here is R cos alpha. This is R cos beta. This is, excuse me, that's R sin alpha. Excuse me, R sin alpha. This is R cos beta. This is R sin beta. Okay, so we've done a good bit there. Now what we need to do is we probably need to resolve our components as well. Okay, but we'll solve it when we have to. Okay, there's two equations if we remember from earlier. One of them is centripetal acceleration or force, and the second one is conservation of energy. Or sorry, the first one is conservation of energy, and the second one is centripetal acceleration. Okay, conservation of energy. mgh1 plus a half mv phi1 squared equals mgh2 equals mgh2 plus a half m v2 squared. Okay, so what we're going to get here is mgh1, which is going to be mg, and we're going to look back at the top. It's R cos alpha plus 0 because there's no speed at the start, and this will equal mgr cos beta plus a half mv squared. Okay, now what we can do is isolate mv squared because we know we're going to use it again. So we're going to have mg r cos alpha minus mgr cos beta equals mv squared. Okay, stop there. Now you're on your second equation. Oh, sorry, it is. I multiplied by 2, so it's, you're right, 2 mgr. It's 2 for both of them, isn't it? Because we multiplied by 2 to get rid of it. Okay. So actually, if I just go back to my last step there before I did this, it would have been mv squared over 2. cross multiply up to 2, and you can get we'll just put 2 in front of both of them, so it'll be a 2 in front of here, and minus 2 mgr cos beta, okay, and then get rid of the 2 here. Alright guys, so that's the first equation done, wrapped up. Now we're on to the second equation, which is going to be the centripetal acceleration, okay? Now, we're only doing the centripetal force at part B, because that's its current speed, okay? Break up your components, okay? So, you need to break up weight into its components. Weight is acting downwards. You need it to be a tangent, and you need it to be parallel to the radius. Okay, this angle here is 90 minus beta. Okay. Now I'm trying to figure out this.
Cos beta going in. Beta's up top.
Just give me a second. Ah, that's beta in there. And using alternate angles, I can get beta in here.
Yeah, so it's cos beta.
Yeah, so this is mg. So this is mg cos beta going in, and mg sine beta. Okay, so what we're going to get is mg. So for centripetal force, we're going to use mv squared over r, the radius, equals, now that's going into the circle, it's going to be mg cos beta minus r. Okay, now does it give us any inkling that it's leaving the plane?
Yes.
Where does it say? Oh,
Part 2.
part 2. But we still have to prove part 1. Oh, we proved it already, did we?
Yeah.
Oh, sorry, we can prove it from our equation in part 1. Just cross off the m's. Cross off the m's, you get phi squared equals 2gr into cos alpha minus cos beta. Now, funny thing then, once I prove that, I'm then not going to use it because I'm used to using mv squared as a whole. So mv squared equals mgr cos beta, and this r now becomes 0 for part 2. So mv squared equals mgr cos beta. I'm going to replace my mv squared here with this stuff to the left, so it's going to be mgr cos alpha minus, 2mgr cos alpha minus 2mgr cos beta equals mgr cos beta.
Sorry, where'd you get that from?
This one here, I inserted that for this part here. Okay? I cross multiplied up the r.
So what the answer for the last bit is?
Sorry, with you now, right? Just let me finish it off. Okay, so guys, move it over one side, and you get 3 mgr. 3 mgr cos beta equals 2 mgr cos alpha. Cross off the mgrs. Okay, cos beta equals 2 over 3 cos alpha. Now, what does it say about cos beta in the question? Cos alpha is 2 over 3. So replace cos alpha with 2 over 3. This means that cos beta equals 2 over 3 multiplied by 2 over 3, which makes it cos beta is 4 over 9. Cos inverse 4 over 9, and what do we get?
1.11 radians.
Sorry?
1.11 radians.
In degrees it's 63.6 degrees, and in radians it's
1.11
1.11
radians.
radians. Guys,